right, thank you. Yeah, well, first I'm going to talk something about MLOps with the application of the open data of Groningen. And mainly it's about using MLflow and data version control within Python to build a more robust ML system. All right, about me. My background in education is econometrics and computer science. Econometrics in Rotterdam, quantitative finance, something completely different from machine learning or what I currently do. And after that, software technology, because I really liked the machine learning that I touched upon a little bit within econometrics. And my working experience, I've always been a data engineer now for 3 years. The first 2.5 years of my professional career, I was at ML6, that's a Google Cloud partner, and I really went on building the pipelines and building machine learning applications on Google Cloud for the Dutch clients. And currently, recently joined the Rijksmuseum the 1st of September, and also a data engineer there. All right, so the agenda of today. First, I'm going to talk a little bit about the goal of this presentation. Of course, we need to introduce maybe MLOps a little bit, if some people in the room that are not familiar with it yet. Then talking about the dataset, what is actually what are we going to apply it on, the requirements, and at last actually doing the thing. All right, the goal. So maybe let's at least at the end there's a little bit of a demo, or at least everything is shown in the slides. But the goal of that specific thing we're going to do is get a sense of the sentiment in Groningen, and specifically with the open data that they provide through the portal. So that is the first requirements of the 2 bullet points. But also tracking our model, our data, and our code, because that is a core thing of MLOps. And now, on to MLOps. What is it? Well, just the abbreviation is machine learning and operations. You put it together. In my sense, that's why I have the little picture on the right side. The ops is always overused because managers like everything needs to be DevOps, maybe also put some security in it. And then now we have MLOps. But yeah, the main message I just want to convey to you is automate it as much as possible. Instead of that, it's maybe manual tasks, and put it in code so you can actually maintain it and build some nice pipelines around it and checks and balances, because that's what you can do inside of the code. There is this influential paper, the Hidden Technical Depth of Machine Learning Systems. It's written by Google like already maybe 10 years ago or something. And just this picture shows really well that when you're having a machine learning system, the machine learning code is actually just a very small block of it. And all of that around it, we just need to do, for example, the data verification aren't we introducing a bias in our data if we are, for example, making a real live system. And as well, monitoring is the neural network we currently have in place in production, still doing the thing we actually coded it for. And that makes it all these different blocks, and actually machine learning or machine learning systems is more software engineering than it's actually machine learning engineering, because it's just a small part of it. And as well, in a different picture, machine learning needs to balance these 3 dimensions actually. Not only do we have the code, which we version on Git, of course, which is the source software engineering, but now we have the 2 extra dimensions as well, the model and the data, because the data is going to change over time, and as well as our model. And how to balance that nicely, at least put it into code. But that's why you have the MLOps maybe guidelines to help you a little bit around there. All right, these 3 slides about a little bit about what MLOps is. I'm going to take a little sip. All right, I was telling to you that we're going to use the open data of Groningen. So what is the location of it? No, it's just the Groningen data platform. There's the specific link. There's also, this presentation will be in the GitHub that's also placed at the end. So if you want to dive yourself into it, or maybe Googling is also actually easier. What is it about? So people, they will make pictures of stuff they see in the public place. And then they tell to Groningen, like, okay, I see here a broken tile or a broken a light of the streets, maybe could you fix something about it? And yeah, that dataset is all about what they actually say in the description, what the picture is about. So there's quite some dimensions about this specific dataset that is actually quite interesting. At this moment, I'm only going to look at the descriptions. Only the description itself are very informative, so that's really nice. So here's a little example. On the right, you see actually what is on the data platform when you go to the site itself. And yeah, you see there are many characteristics like the begin date, the end date, but the description, and also the media on the downside. So for example, this description is about a person who saw some bikes in the canals. Of course, very Dutch to have the bikes in the canals. But it was there still also the 31st of October, so she is getting a little bit worried. And yeah, there's also extra bikes getting introduced there. So that's what people just say on this specific platform. We also have another one which is maybe even more specific. He really hates the trees that is in front of his building because of all the leaves and the branches. And while you're at it, if you're removing it, could you also add 2 private parking spaces for me? So it's just nice to have a look and scroll through everything what is basically in there. But as well, there is so much of information that is in there, because first of all, you can also see which number the person is living in. But second of all, it's more is he happy about where he's living? Is he missing something? Yeah, both of these are at least in there. But I'm only going to look at sentiment, but maybe this can be something that people research in the future. All right, the requirements. Of course, that's why we're here, Pygrunn. We need a runner. Going to run it in Python, so that's why it's here. For the sentiment, we're going to use Bertje, which is hosted on Hugging Face, and it's actually made by the University of Groningen. Yeah, it's just so nice that you can have these transformer models and that you don't need to build them by scratch, and that I can just demo it to you. The machine learning framework specifically here is PyTorch. You can, in Hugging Face, you can choose whether you want the TensorFlow or PyTorch, but at least chose PyTorch. And then the tools that I shortly introduced into the beginning is DVC, so data version control. Basically, you can say it's a Git for data. Your models are also data, so you can actually also use it for models. But MLflow has a little bit of a nicer UI, so that's why, for at least for experiment tracking and for keeping track of our models, we're also introducing MLflow here. All right, let's take another sip before we dive into the code. So another time, the problem statement. I put this GitHub repository if you have your laptop. I don't see any laptop, so then you can follow along. But the problem is, apply sentiment analysis of the remarks of the public spaces of this specific open data set, and then while keeping track of our data and as well as our experiments with DVC and MLflow. So in this specific GitHub page, there are these 6 specific steps, because you are tracking your model and as well your data if you're actually changing something in, for example, the data, or if you're changing something with your model. But for the sake of time, I'm only going to do the first 2 parts because that also introduces the best DVC and MLflow. All right, now first step is downloading the data. This is actually very simple REST call. There you see the ckn.data platform. So there's not specifically the Groningen data platform, but this is the open source thing that actually hosts the interface to get the data. And then we gonna write it locally to the data/datagrun.json. And now let's get into DVC. It's actually pretty similar to Git, and therefore it's very convenient to use it well. First you need to initialize it, DVC in it, just like you maybe, first you need to pip install, of course, but then initialize it on the specific project you're working on. And then for this example, I also set up the remote repository, because also Git is maybe a little bit worthless if you are doing it on local and just for yourself. So having a remote storage is, at least in my sense, a requirement for it. So you can put everything there. I just chose for Azure Storage here specifically, and yeah, you can see the documentation if you need to add some other sources. So maybe going specifically in the folder structure, what happens there then? Maybe. All right. So I have the data folder. I have the source folder. In the source folder, there's all the code, which is now in a way because I don't want to show you specifically the data. You can actually see the data Pygrunn. That's written here because the previous REST call put it there. And what this DVC init and also the DVC remote storage is going to introduce is the extra folders. Specifically, your config.local is going to be my local config to where my remote repository is, because in this state I put a secret key there. I don't want this to be on GitHub, so that is going to be locally on my own configuration. But the other config is actually saying that where the location of the data is going to be, and as well DVC ignore, because it's just like git ignore has its own ignore file. Then going into specifically more the details, then we're going to add, just like with Git, the data to track it. So what you're going to do then is DVC add the data/data Pygrunn. And after that, that's it maybe for DVC just. And then that's where maybe the more strong point comes in, is that we're going to push that, not the data, but the reference to the data to Git. That's what the last part is about. So the first line there is that we're going to put the reference to Git. Second one is that in our git ignore, we also introduced please ignore the data, because we're only going to store the reference on Git. And then commit it and push it, of course. That's what these extra folders are getting introduced for. So you see there the specific git ignore there is to ignore the data/data Pygrunn.json. But the data Pygrunn JSON DVC, the specific reference, that is actually pushed to Git. Let's show a little bit what is actually going on there then. On the left side you see the snapshot of Git. So what this DVC file looks like, you can see here it's really only the reference to its specific location, that's the hash of the data, and as well the path that is locally stored there. And then when I go to my my remote storage, the DVC there, if you see the location, if you see the location over here, the hash is you can see the hash, the E0, and then the file. So that's specifically where the data is put on here. So you want the reference of the data on Git, and we want the data itself in a blob storage somewhere remote. All right. So on to the second part. This was the DVC part. Now running an experiment with our model. So for MLflow, we need to write a specific wrapper, because then MLflow can bring it to an MLflow flow format. That's first of all needed before you can put it in MLflow. And at the same time, you can potentially serve from this more general format, instead of that you have to write the REST API around your model itself. So that can be a great easy step to serving your model. So what you see here, the init and as well the predict that's needed, because if we're going to wrap from this specific MLflow.pyfunc here at the top, we need these two classes. So first, in the init phase, we're actually gonna import the batch model from a Hugging phase, do the tokenizer, and then also the sequence classification. And in the predict, we're gonna put it together and actually use the input that we get when we call the MLflow.predict function. Then, so this was just a wrapper, as it's stated. Now we're gonna talk to MLflow as well. At the moment, this is a locally one, but you can also, just like with DVC, change your config. So that's also running on Azure Cloud specifically, if you are or any other cloud, if you're working with multiple people there. And Well, the second part here, just defining the signature. So what can the MLflow model expect as an input? What can it expect as an output? You can even also put some examples in there specifically if you want to make it easier for people to use your model. That's even better, of course. And then the last part, the MLflow.start run. Here's actually where we're going to log our model to MLflow. And to actually, we put the wrapper that we previously made in this Python lower Dutch model in the sentiment analysis, and just by calling the log model, we're going to log it to MLflow. Which logging means making some local runs and as well starting some local runs. If you want to actually use the UI, which I stated is actually the most nice feature about MLflow, instead of maybe putting your models in DVC itself, you can start the run here with MLflow UI. Then the third line will get outputted by the command line, and yeah, you can just click on it and you will have this overview of MLflow. Well, just vary the default experiment I used here. And as you can see here, our model here will be specifically stored in the Python models, because it's only a logging. There is not really an experiment there. We don't have any epochs that we trained on or a certain loss. But for the other ones, you actually see that it is there. That's also going into the later steps actually. What is actually also nice is, for example, the transformer package of. The transformer packages, they automatically put out some metrics already in MLflow. It detects if you have an MLflow the environment set up, at least for your default environment, and then it actually can output already a little bit for you. So that's what actually happened in these lower parts. But now going a little bit in the log model that was just stated here. When I click on the specific models or the specific model, so this is the PyFunc, the specific wrapper that we wrote around it. We can also get a little overview of what's actually in this specific PyFunc. And even nicer, if somebody else is gonna use this, they can just copy paste this, and then they can actually run a prediction on the specific one. And on the top left side, you see all the other data stored there as well. So the moment that you load the model, these will get stored, and you will have that specific model points. Although short, or at least a little side note, if you're running, for example, PyFunc, you also always need to have the the wrapper function locally stored. So that will not get stored within this the MLflow format. That's more when you really Dockerize it. Then that will also get stored there. But at least, little side note. All right. So now let's put a simple prediction actually on it. We're gonna open the data.grun. All right. There is some pre-processing done before it. So I only want to get the predictions actually from it. And then, as stated in the UI of the MLflow, I just copied the link over here, put it in the load model, the function from MLflow, and then do the prediction on it. So this .predict is gonna call the predict function of the wrapper that we made that before. And yeah, just some simple writing back to JSON, but now I'm gonna show you 3 results specifically then for this model. Although yeah, it's a little bit of a complaint database. This public space, because you're not gonna post something very positive, or at least you're just gonna say when something is wrong. And it's also, it would be nice to even explain a little bit from why is certain stuff angry and why is certain stuff negative. So I think, for example, you have the gevaarlijk and the kapot is probably very negative, while the first one is just pretty indeed neutral. All right, so very brief now. This is a little bit of my talk about these first 2 steps. I would highly encourage you to first of all make the people of Groningen more happy, because these is 2 sad phases and just 1. Maybe we can improve a little bit on it, but maybe let's not all do only positive text. But yeah, this was my talk. Well, so he's asking what you also have the Git large binary storage, but what are the advantages above DVC? To be honest, I don't know the binary storage of Git at all, so that is a nice thing. Maybe I'll just research after this. But yeah, well, you can probably also use that. Yeah, I don't know. It's yeah, but I guess you probably also can specify that as well, or at, at least what you want to put on Git is the reference and not the data itself. And if the large binary storage of Git can do that, yeah, then it's fine. And I think DVC is a little bit more nice because it's also open source, so people are like actively contributing to it instead of that it's maybe something proprietary or half proprietary for Microsoft. That's all I can say. All right. Okay. Yes. At least from what I saw, or specific, yeah, just demos from the DVC people itself. What I did in the demo is duplicating their specific data set, and you saw that actually the MB is really almost doubled. So I have a feeling there is no real deduplication there. Yeah, what you can do is just zip it and then do the zip through DVC, if you're really concerning about it. But at least it's not maybe a standard feature, or that you need to research a little bit more about that into the code itself.
How would you incorporate DVC in MLflow if you want to track which version of the data you used that produced a model in a certain day?
Well, yeah, so in this specific MLflow, you have this version. So that version is the GitHub yeah, hash, the first part of the hash. So with that said, you can check out that specific Git hash, and as you store the reference of the data there on Git, that is going to be the ground truth for that yeah, specific one. So, but you still need to make sure that people then actually commit and push the DVC stuff, because otherwise it can still be outdated indeed. But I would say then there the Git is always leading in that sense. And from that you can get the reference and the specific data from it. Did I answer your question correctly, or am all half? Okay. Yeah, well, like, or at least MLflow, it will format in its specific MLflow format. So you can easily yeah, host or serve your model. And then indeed you can, when you hosted that specific one, you can specify these hooks and then logs metrics to a specific place. So once you have it in there, you can serve it through MLflow. And yeah, for pre-processing or putting it somewhere to the hosted version, then you need something different for it. But at least for yeah, the moment you host it, you put it in the MLflow format, and then you can yeah, use that for it. Well, so at my previous company, I mainly work with Kubeflow, so that is also very similar to MLflow. Although Kubeflow is really that everything runs on Kubernetes in the background, so it's very scalable. So you define your machine learning pipeline. So what I just did is only the model itself. But if you have a pipeline itself, then you have the pre-processing step, which is a specific container. You have the prediction, which is also a specific different container. And then you can, on Kubeflow, run them, or at least these containers will get most optimally scaled down or scaled up, which is what I or at least what I noticed for MLflow, that is a little bit missing. So I think that is a little bit of a drawback there. And what I didn't use much in the past is DVC actually. And but it's while I'm researching it, I think it really fills up like gaps, because there is always, of course, we can do the experiment tracking, but it's very hard to find out which specific data set is in there, also which specific model. We only know maybe the Git hash that is then stored on here, but the other two artifacts are still like very variable. So that's, I think, right now DVC solves a little bit of a problem for me, because it then you specifically store the reference instead of that you maybe make this yourself, so you can just use this package for it. But most of the experiment tracking platforms really only track the experiments, and that's all, not more than that. Or at least you have to go through many hoops, and at least you need to count that as well at the beginning, because there will be the question, okay, can you maybe run this specific model on the data set that we had a year ago? Is it still going to be enough? And that is what I at least wanted to do a little bit with these six steps. Freudian slip there. So that. Mm-hmm. Yeah, well, like, but in Kubeflow, everything is a Docker container then. So every artifact is then a specific Docker container. But in that Docker container, you're probably gonna maybe query to a database. And that specific part is maybe not locked, or you specifically need to put it somewhere on a place. And at least it's not put there automatically. So you, for example, you have maybe an OLAP database that is hosting your data. So inside of your Kubeflow, just getting the data, you do a specific query. And yeah, well, inside of Kubeflow itself, maybe it can store the data there if you want it, but not per default. It just stores it on the not persistent disk that itself is running on. So yeah, you still need to have some kind of history database, or at least what at that moment of time you used it, in my experience. But if you maybe now have something, of course you can. Okay. I don't think so, because well, all these managed services, they really do everything for you indeed. So it's only if you're doing something from scratch and on your own on-premise environment.